Earth, a 4.5 billion-year-old planet, still evolving. As continents shift and clash, volcanoes erupt, and glaciers grow and recede, the Earth's crust is carved in countless fascinating ways, leaving a trail of geological mysteries behind. In this episode, Europe's greatest mountain chain, the Alps, is explored. Home to some of Europe's highest peaks, longest glaciers, and sheerest rock faces, the Alps are one of the most dynamic and dangerous mountain ranges on the planet. A mysterious land where whole mountains collapse in on themselves, and where its rocks once lay entombed at the bottom of the sea. Scientists have been hunting for clues hidden inside the rocks, deep within the ice, and upon some of the most famous summits in the world, to understand how the Alps formed and continue to evolve. Clues which also provide a window into the formation of the Earth itself. With more than 100 peaks rising higher than 12,000 feet, the majestic Alps tower over Europe. The mountains are a huge physical barrier, 750 miles long, 125 miles wide, and spanning 7 countries. The Alps divide northern and southern Europe. Home of the iconic Matterhorn and Western Europe's tallest mountain, Mont Blanc, the Alps are one of the world's highest mountain ranges. But the majority of these peaks formed only 30 million years ago, making it one of the youngest mountain ranges on Earth. And for centuries, geologists have pored over these fabulous rock formations to figure out how mountains are made. But the first person to uncover a crucial clue to the Alps formation was, surprisingly, a 16th century Renaissance man, Leonardo da Vinci. He was not only a great artist, he also had a brilliant scientific mind. Da Vinci was a natural detective who saw the world around him as a huge mystery waiting to be solved. He focused his inquisitive scientific mind on the Alps at a time when most scholars believed the Earth was flat. Da Vinci had heard tales of an extraordinary discovery embedded in the rocks, and in 1510 he trekked high into the mountains to take a look. At 7,000 feet, he found what he'd been looking for: fossils. He knew these creatures came from the sea, that they could not have lived in the Alps. So how did they get there, more than 100 miles from the nearest ocean and thousands of feet above sea level? The 16th century explanation provided by the powerful Catholic Church decreed that the marine fossils must have been washed up during the time of Noah in 2300 BC. The Holy Scriptures describe how God, sickened by the wickedness of mankind, inflicted a terrifying deluge of water upon the earth. All forms of life were annihilated, except those sheltering on Noah's Ark. The great torrent of water that flooded the earth must have washed some of the sea creatures 100 miles inland. But Da Vinci did not believe this explanation, and continued his investigation as to how the fossils got there. In the Santis Mountains, northern Switzerland, 500 years later and 7,000 feet above sea level, it's still possible to see the fossilized remains of sea creatures that so intrigued Da Vinci.
Here we have a rock which is almost covered with fossils. For example, here, cross-section of a clam. Here below we have the skeleton of a coral.
Poring over the fossils, Da Vinci carried out an ingenious piece of detective work. He found the fossilized remains of 2 shelled creatures that amazingly still had both halves intact. If the Church's explanation of a cataclysmic flood were true, then the torrent of water would have torn these delicate creatures apart. Da Vinci proposed that these fossils had formed under the ocean and that some other force had brought them high into the mountains. Modern-day scientists have identified the species fossilized in these rocks and can accurately pinpoint when they lived.
The fossils we see here actually lived 100 million years ago in a warm tropical sea.
This ancient tropical sea teemed with life and rich coral reefs. The sea floor was covered in urchins, clams, and other species, many now extinct. Just as Da Vinci had imagined, when some of these creatures died, they were preserved intact. Their shells then became buried in the sediments at the bottom of the sea and preserved as fossils when the sediment turned to rock. But what could these fossils reveal about the formation of the Alps? Again, it was Da Vinci's exceptional powers of observation that helped unravel the mystery. He noticed that the spectacular fossil-bearing rock, known as limestone, was laid down in layers several thousand feet deep. 400 years later, it was discovered that along with the fossils, hidden in the microscopic structure of limestone, is an essential clue to solving the mystery of how the Alps formed. Remains of trillions upon trillions of seashells. Limestone forms as tiny sea creatures sink to the bottom of the ocean. Piling on top of one another, they compact together under their vast accumulated weight, forming layer upon layer of sedimentary rock. The Santis Mountains, like large areas of the Alps, are made almost entirely of the shells of dead sea creatures. Beds of limestone here are several thousand feet high, evidence of the extraordinary amount of sediment that was laid down on the ancient sea floor.
We have here a massive package of limestone, layer above layer of sea floor. And this was brought up in an upright position during the building of the Alpine mountain chain.
Ancient clues reveal the origin of the Alps. Marine fossils are evidence that these rocks were once covered by a tropical sea. And rocks made from trillions of microscopic seashells reveal how entire mountains formed from sediments laid down in the ocean. Da Vinci suspected that part of the Alps had formed beneath the ocean, but how had these originally flat layers been upended?
Leonardo's explanation was that some kind of force have brought the fossils high up to the mountains, but he actually couldn't explain then the driving forces of this movement.
After Da Vinci, it would take scientists another 400 years before that part of the mystery was solved. The Alps. This jagged backbone of Europe was lifted thousands of feet above sea level and 100 miles inland. Many of the alpine rocks once lay flat on the sea floor. An extraordinary force twisted, folded, and turned this land upside down. But what was this force? And how could it move great swathes of solid rock? In the 1870s, Swiss geologist Arnold Escher and his student Albert Heim were drawn to a strange line etched in the Chinglehorn Mountain. They traced the line for 30 miles. Out of reach for most of its range, they found one location where this line can be examined in close-up, near the village of Elm, eastern Switzerland. The dark line can clearly be seen here beneath this strange overhang. Above it, Escher and Heim identified a layer of ancient sedimentary rock. But strangely, beneath the line they found a layer of much younger rock.
Underneath we have here the Fliege. These are slates which are about 35 million years old. And on top we have the Verrucano, which has formed about 260, 270 million years ago.
Escher and Heim were confused. The rock formation simply did not make sense. If both layers were formed by the buildup of sediments, how could older rock lie above the younger one? Studying the twists and folds in the surrounding mountains, Escher and Heim came up with a theory as to how these rocks switched places.
Just imagine we have one big sheet of sediments, and one part of the sediment of this sheet is pushed over the others. That's the way we get older sediments on younger sediments.
A gigantic horizontal force pushed these older rocks a distance of 30 miles over the younger layers. The line between them, where the rocks scrape over each other, is called an overthrust. Escher and Heim's discovery revolutionized our understanding of how mountains are made.
This outcrop, actually, it's a close-up of maybe the most famous overthrust in the world, the so-called glorious overthrust. And there are only a few places where you can go so close to it.
This site is merely a close-up of a massive geological phenomenon that created the Alps. Sitting above the Glarus Overthrust is a mountain range with peaks over 11,000 feet high. It's a reminder that some awesome power created the Alps, a force that can literally move mountains. But what has the power to push billions of tons of rock? Scientists now know that such a colossal process can only happen when two continents collide, driven by the forces of plate tectonics. Plate tectonics is the process by which giant plates of the Earth's crust move slowly across the planet's surface, propelled by vast currents of molten rock deep within the Earth. As this happens over millions of years, continents collide and split apart, and oceans form and disappear. But if the Alps formed as a result of a massive collision, what continent had crashed into Europe? The answer lies entombed in one of the Alps' most famous landmarks. Hidden by clouds, it's frequently hard to see.
There it is, finally.
The Matterhorn's unique shape has made it one of the best-known mountains in the world. At 14,692 feet, it's one of the Alps' highest peaks. Hidden within the body of this mountain is another major overthrust. Here, rocks from the sea floor lie above the European bedrock. Taking a closer look at the layers formed under the sea, Dr. Helvig finds a green-tinged rock.
The rocks we are looking at here are called green schists.
These coarse crystals reveal that this rock erupted as lava at the bottom of the ocean 100 million years ago. But in the early 20th century, scientists discovered something even stranger. An unusual layer of rock caps the mountain. This upper layer is a gray rock, called gneiss. But when geologists traced the origin of this rock, they found it did not come from Europe and was 200 million years older than rocks from the sea floor. This rock belonged to a 2 billion year old continent 600 miles to the south, Africa.
The upper section of this alpine sandwich, it consists of rock which come from Africa. The middle part are the rocks from the oceanic crust, and the lower part then are the European rocks.
this is evidence that the Alps formed because ancient Africa collided with Europe. The result? This whole mountain is composed of 3 rock types.
From a geological standpoint, it nicely combines the whole Alpine story. So it shows the most important aspects of the Alpine history right there within one mountain.
But how exactly did rocks from the sea floor get sandwiched between 2 continents? Detailed studies and dating of the Alpine rocks have revealed that 90 million years ago, Africa pushed towards Europe, squashing an ancient sea, the Tethys Ocean, that lay between them.
As Africa plowed into Europe, it first destroyed the ocean that lay between them and piled it up in thin slices, much as a bulldozer tears up the ground in front of it. These slices were then piled in front of the bulldozer that makes up Africa. So we began to develop this large pile of deformed rock that is what today forms the Alps.
The ocean floor was crumpled in front of the advancing African continent, bending, folding, and breaking as it went. 30 million years ago, the Alps were literally pushed up onto Europe. Africa was thrust over and above the other layers to form the sandwich of rocks that would become the Matterhorn. A jumble of rocks had been folded and molded by violent processes and uplifted 22,000 feet, as high as the Himalayas today. Scientists investigating how the Alps rose up off the ocean floor have uncovered a 30-mile line in the rocks, the boundary between older rocks thrust above younger ones. And gray, gneiss rocks at the top of the Matterhorn prove that Africa collided with Europe, creating the Alps. But for the last 30 million years, some other monumental force has eaten away these great peaks. What has caused this entire mountain range to lose nearly half its height? 30 million years ago, the Alps' highest peaks towered 22,000 feet into the air. Today, the tallest peaks are almost half this height. Unraveling the mystery of why and how the Alps are disappearing is important to the 14 million people who live in and around them. Ilhorn Mountain, an extraordinary peak in the Swiss Alps, provides an essential clue. This mountain is almost 9,000 feet tall, but hollow at its center. Ilhorn is rotten to the core. This massive hole is forming as the mountain collapses in on itself. But what monumental force is pulling this mountain down? It's made of a loose, unstable mixture of rock and mud that originally came from the ocean floor. In winter, this mixture of rock is glued together by ice, but in the spring thaw, it becomes loose.
Here you can see the fact that the rocks are very highly weathered. You can easily, in fact by hand, pull them apart. You can imagine that in winter when the water goes behind the rocks and freezes, that it could actually mechanically loosen the rocks, and in the spring they fall down. The whole mountain is composed of these rocks. It's basically just falling apart.
A combination of weak rocks and the natural action of freezing and thawing has resulted in a crumbling mountain. In the last 10,000 years, 100 million tons of Ilhorn Mountain has eroded, and in the process hollowed out a vast new valley, the Ilgraben. But where has all the rock gone? Dr. McArdle has come to explore a deep, seemingly dry riverbed, which runs down from the heart of the mountain and into the river Rhone. The evidence is hidden beneath the village and vegetation. a large, fan-shaped platform of rubble, 1,500 feet deep and over 1 mile square.
This structure is built from the sediment delivered by the Illgraben catchment. All of the sediment that you see has come down from the mountain.
But this dry riverbed presents a mystery. How did vast amounts of debris get transported down from the mountain? The Swiss village of Susten, ground zero for the investigation, is in a constant state of alert. A few times a year, the ground shakes here as if a gigantic freight train is thundering through the village. In a flash, this dry channel is flooded by a river of rock. Thousands of tons of debris flow down from the Ilhorn mountain.
Anywhere between 3 and 5 times a year, there's a large wave of sediment moving downstream at anywhere from 10 to 20 miles an hour with a flow depth on the order of up to 10 feet. And it moves down the channel rapidly, and anyone who's in the channel, of course, is in danger.
Every time it rains, debris cascades down the mountainside, making this one of the most active debris flow zones on Earth.
The Alps are basically being washed down from the mountains through the rivers and into the lakes and the valleys further downstream.
Ilhorn is an extreme case of an entire mountain in the process of decay, resulting in one of the most dangerous mountain terrains on the planet. But inherently unstable rocks are found right across the Alps and have created some of the Alps' best beauty spots. Oschinezee Lake is a mile above sea level and half a mile square. But in theory, this lake shouldn't be here. The streams that pour off the mountain should run straight down the valley unobstructed. A clue to what created this high-altitude lake can be found 1,000 feet up on the surrounding slopes.
As we look up on the hill slopes, we see these very large fans of debris that are coming down off of these unstable slopes. Where we see this sort of smooth bedrock that's dipping towards us, this is prime territory for landslides.
When these mountains formed, flat sheets of sedimentary rock were thrust up to rest at extreme angles. The joins between these stressed and fractured rock layers frequently fail, causing huge layers of rock to shear off the cliff faces.
Much of these open slopes are probably the result of sheets of rock peeling off and forming large landslides.
It was a catastrophic landslide that caused this lake to form 15,000 years ago. The entire side of the mountain sheared off, blocking the valley and causing stream water to back up and create one of the Alps' most breathtaking landscapes.
It's all about gravity. Gravity is what ultimately brings down mountains. Rivers come in, debris flows form, landslides form, and this sort of process is very common throughout the Alps.
Steep slopes and unstable rocks have created a mountain range that is ever-changing. In only a few thousand years, gravity will also destroy Oschinezee Lake as debris flows fill it up. Over the last 30 million years, the Alps have fallen down on a massive scale, in places decreasing in height by 10,000 feet. So what has happened to those thousands of feet and billions of tons of missing rock? A clue can be found in the rolling hills a few miles north of the Alps. At Eckiville, this rock outcrop contains an extraordinary collection of stones.
These are large cobbles, stones that have come from all over the Alps. So if I look at some of these, for example, this small white and black rock, this is a granitic rock that comes from the center of the Alps, somewhere very close to the Matterhorn. And we see throughout this outcrop rocks that come from different parts of the Alps.
Rocks from hundreds of different scattered locations have traveled over 150 miles before being dumped in this geologic rock graveyard. But it's the amount of material here that's mind-boggling. These hills are made entirely of rock debris from the nearby Alps. At 100 miles wide and 500 miles long, they stretch in an arc round the Alps, running through France, Switzerland, and Germany. There's enough material here to cover all of North America in 100 feet of rubble. Could this be where the thousands of feet of missing alpine rock have gone?
A big mountain range like the Alps is heavy, and it weights down the crust, forming a depression all the way around the mountain range.
A multi-trillion-ton mass of rock was pushed up on land as Africa collided with Europe, creating the Alps. The weight of the rock caused the European crust to sink, making a huge depression in places over 2.5 miles deep, the Molasse Basin.
Now the importance of this depression is it's a trap. All the sediment that we see eroding off of the Alps is trapped in this basin and ends up sitting there.
Dating of these pebbles has revealed that ever since the Alps were created, rivers have washed alpine debris hundreds of miles downstream, dumping the rocks in this gigantic basin.
So these rocks that we're looking at here are the debris, the detritus that's come off of the Alps over the last 20, 30 million years. These particular rocks are almost 25 million years old, and what we see are cobbles. We see little pieces of all the different rocks that we see throughout the Alps.
For 30 million years, the debris eroded from the Alps has been dumped in a 30,000 square mile bowl, creating this rolling chain of hills to the north of the Alps. This is where the missing mountain rock is. Put it all back together, and once again there'd be mountains as high as the Himalayas. Scientists have discovered how the Alps have almost halved in height and where the missing rocks have disappeared to. The clues are inherently unstable mixtures of rock resulting in whole mountains falling apart, debris flows on steep cliffs, proof that weakened layers of rock shear off from the mountainsides, and a graveyard of pebbles from all over the Alps, evidence that these mountains have been washed away. But then 2 million years ago, the landscape changed dramatically. Vertical cliffs were carved into the Alps, and giant spikes of rock poked through the clouds. Another mighty force had begun to resculpt the Alps. Over the last 2 million years, a blink in geologic time, something has rapidly and radically transformed the Alps, gouging giant peaks and sheer rock faces. The most notorious rock formation being the Eiger in southern Switzerland. The infamous north face of the Eiger is a 6,000-foot vertical climb. It's a terrifying, unrelenting ascent. Climbers face gale-force winds, freezing fog, rock falls, and avalanche, giving the Eiger the reputation as one of the most formidable climbs in the world. Nicknamed the Murder Wall, since 1935, more than 60 climbers have died here. How giant climbing walls like this were formed had been a mystery to geologists until 1837, when Swiss scientist Louis Agassiz noticed similar cliffs at lower altitudes, known to have been made by a colossal force: glaciers. Over 1,000 glaciers wind their way through the alpine valleys. Imperceptible to the naked eye, these giant rivers of ice slowly flow downhill. This time-lapse of the Alps Glacier, taken over a period of 3 years, reveals how glaciers can move tens of feet a year. And where two glaciers meet, a stripe of rock sits on the surface, proof that something extraordinary is happening beneath the ice. A force which can transform jagged rock into a surface as smooth as glass.
We see here a smooth rock face
which was formerly covered by ice. Underneath the ice there's this rocks and sand, and the ice carries this stuff with it, and it acts like sandpaper and polish this rock.
But polishing alone cannot account for the formation of the Alps' jagged peaks and the north face of the Eiger, where the sides of entire mountains have been ripped off. More evidence of the awesome power of glaciers can be found on these granite slabs. Deep cracks penetrate the body of the rock.
The ice was flowing over this rock face, and the ice could enter this crack.
Meltwater forming beneath the glacier seeps into the cracks, refreezes, and splits open the rock. Weakened and fractured, huge chunks of stone are ripped from the bedrock. Vast amounts of rock are plucked and ground from the mountainsides and dumped in the lower, warmer valleys when the ice melts.
So here we are at the end, the snout of the glacier, and here debris, water and rock boulders. This has been eroded by the glacier, transported and moved to this place. And this is the essential process how glaciers form the landscape.
But how could glaciers have carved the north face of the Eiger and other mighty peaks, which rise thousands of feet out of reach of the abrasive ice below? Agassiz came up with a radical theory. He noticed these high rock faces were scarred and gnarled. They had clearly been gouged by ice, like the glaciated valleys he'd found at lower altitudes. Piecing the evidence together, he concluded towering cliffs like the 6,000-foot Eiger were the handiwork of ancient, gigantic glaciers. But if Agassiz was right, where did the huge glaciers come from? The evidence lies locked inside Europe's biggest river of ice, the Alps Glacier. A massive 14 miles long, it covers an area of more than 45 square miles and is up to 3,000 feet deep. The Alps Glacier in southern Switzerland has helped scientists understand how all alpine glaciers form. The source of the glacier is high up in the mountains, where altitude brings freezing temperatures and heavy snowfall. To explore how delicate snowfall becomes a giant slab of ice, Dr. Bauder ventures deep into the heart of the glacier. This frozen passageway, 32 degrees Fahrenheit and 60 feet deep, offers tourists and scientists a unique window into the formation of a glacier.
Here we can see the inside of a glacier. We can see inside the ice. We see here layers of air bubbles. And there are different distinct layers visible here, here, here. And they represent individual years when this ice has been formed.
The glacier grows by the buildup of layer upon layer of snow. The newly fallen snow traps pockets of air between the individual snowflakes, forming layers of bubbles. As more snow settles, the flakes beneath become squashed, making them stick together to form ice. Forming over thousands of years, the amount of ice contained in a single glacier can be staggering. It's been estimated that the Alps Glacier holds 27 billion tons of water, enough to provide every human on Earth with 2 pints of water a day for the next 6 years. It's the air bubbles trapped inside the ice thousands of years ago that hold the key to what carved the Alps' distinctive shape.
In the air bubbles, air is stored from the time when the air bubbles have been formed. So we can analyze the chemical composition inside there and learn about climatic condition at that time.
When scientists analyzed miniature time capsules like these, they found air over 12,000 years old, with surprisingly low levels of the greenhouse gas carbon dioxide. This meant that more heat was escaping from the Earth's atmosphere, causing global temperatures to plummet. Similar studies have revealed that for the last 2 million years, the Earth has been gripped by a series of ice ages. Agassiz's theory was confirmed. 2 million years ago, an enormous ice sheet engulfed the Earth's northern hemisphere. The Alps were buried in ice, almost 2 miles thick. It was so deep that only the tips of the mountains poked out above the ocean of ice. As the ice moved, it whittled lone peaks and tore steep rock faces high in the Alps, leaving its legacy on the landscape. It was during this time that giant glaciers carved the infamous north face of the Eiger. In their mission to discover how the Eiger and other great peaks in the Alps formed, scientists have found cracks in granite bedrock, evidence that glaciers cleave masses of rock from the mountainsides, and low levels of carbon dioxide trapped inside ice bubbles prove that giant glaciers once carved immense rock walls and pinnacles which now tower over the landscape. 10,000 years ago, the great ice sheets melted, leaving their mark on the Alps. But today, the Alps are falling down at a phenomenal rate. Something has propelled them into a new and violent phase of their evolution. The Alps are falling down at an accelerated rate. Millions of tons of rock are crashing to Earth. A clue to what strange force is at work here can be found high up in the mountains, where the remnants of the last ice age lurk. Alpine glaciers physically prop up mountains, binding the rock together. But these icy rivers are changing shape.
What we see in the background here are glaciers which are separated by rocky surfaces which are looking very fresh because they had been ice covered in the last few hundred years. If you look across here to Theodule Glacier, we can see that actually right next to the ice there is some grayish material next to the brownish material. That's exactly the limit up to where the glacier was in 1874. So you see how much of this ice has melted down in these 130 years.
Scientists believe global warming is melting the ice faster than at any other time in the Alps' history. And as the glaciers shrink, they expose steep, unsupported cliffs that are prone to fall down, increasing the risks of landslides. But scientists have discovered another way melting glaciers are weakening the Alps. When these frozen reservoirs melt, millions of gallons of water gush downhill, feeding the great rivers of Europe. Like liquid sandpaper, this torrent scrapes over the rocks, hollowing out the land at an accelerated rate. The dramatic evidence of this dynamic process can be found in the valley of Lauterbrunnen. Echoing through this valley is the sound of one of the loudest and most spectacular water features in the Alps, Trummelbach Falls.
You can just feel the pulsing of the water. This is the name Trummelbach actually means drum sound, and this is reflecting this pulsing, throbbing that we can hear and feel from the water flowing down through these caves.
Trummelbach is a spectacular glacial waterfall. Over 5,000 gallons of meltwater a second hurtle down from glaciers on the nearby Eiger and Jungfrau mountains. Over hundreds of years, this abrasive jet stream has sliced through the mountain, creating a narrow canyon. Each year, from the Swiss Alps alone, there's enough rock removed by the glacial meltwaters to create a mountain more than half a mile high. But Trummelbach, like other alpine waterfalls, is living on borrowed time. As meltwater thunders down the waterfalls, it cuts into the rock, weakening it. Over time, these steep cliffs left by the glaciers crumble, replaced by ever-deepening river valleys.
Today, the rivers that are now returning are trying to carve a river valley, which has a very different shape and different form, changing this landscape. All of these processes come in and destroy that high relief that the glaciers have left behind. Very dynamic processes, very rapid erosion, very rapid processes that cannot be sustained over geologic time.
For the last 150 years, global warming and the resulting glacial melt has caused a huge amount of erosion. Experts warn if this warming trend continues, the Alps will be ice-free by the end of the century, and fear these great mountain peaks will tumble down even faster. Weakened rocks and the increased risk of catastrophic landslides could spell disaster for villages and resorts high up in the Alps. But a look back to ancient times reveals that the Alps have been in meltdown before. In the autumn of 218 BC, the mighty Hannibal led an army of 50,000 men and 40 elephants across the Alps to attack the Romans. An arduous 15-day trek across the most treacherous terrain in Europe. Many men fell to their deaths along the perilously narrow tracks. But Hannibal's audacious plan paid off. His army pushed on through Italy to defeat the Romans. Today, Hannibal's route is virtually impassable, blocked by ice and deep snow. Scientists realize that when Hannibal crossed the Alps, the mountain passes must have been ice-free, and the glaciers must have retreated further back than they are today.
It may have been a bit of a walk through the forest for him, at least much of the way, and certainly an easier time to travel through the Alps than we would have today, for example.
Past changes in the Earth's tilt towards the sun have caused glaciers to melt and refreeze in response to a fluctuating climate. If history repeats itself, glaciers will sometime in the distant future naturally return to the Alps.
These advances and retreats of the ice are very important to the overall rate at which the Alps are being eroded.
It's this natural cycle from glaciers carving cliffs to rivers cutting valleys and back again that has created a mountain range that is ever-changing. And it's this natural process that will ultimately destroy the Alps as we know them.
The Alps are slowly being destroyed. We'll probably see more glacial advances and retreats that will begin to erode them down. So if we were to come back in 10, 20, maybe 100 million years, we would still find a mountain range here today. The Appalachians of eastern US, for example, remain at least a small subdued mountain range, and that will be the future of the Alps.
The Alps will shrink to half its size and become a mountain chain less than 6,000 feet high. Stunted in height, no glaciers will cap these mountains nor feed the great rivers of Europe. Millions of years from now, the vast lowlands of France, Germany, and Eastern Europe could one day be barren and parched. Scientists have discovered how the Alps formed and why they're tumbling down. Marine fossils and limestone made from trillions of seashells are proof that alpine rocks formed at the bottom of the sea. Gray gneiss rocks at the top of the Matterhorn are evidence that Africa collided with Europe, forming the Alps. Landslides are proof that sedimentary layers and sometimes whole mountains are inherently weak and collapsing. Gases trapped in ancient ice bubbles reveal that giant glaciers carved out the rugged landmarks of the Alps. And shrinking glaciers and waterfalls are weakening the Alps, creating a skyline which is constantly changing. Since they were created, the Alps have continued to evolve. One of the most varied, spectacular, and intensely studied mountain ranges on Earth, understanding how the Alps were made has unlocked deep secrets of the powerful forces that shape our planet.